The external pulse commutation is a forced commutation method. In this method, a pulse of current obtained from an external voltage is used to turn off a conducting thyristor. This conducting thyristor is the main thyristor. As you can see in the figure, the main thyristor supplies the necessary current to the load resistor. The main thyristor gets the current from an external supply Vs. Vs is the voltage of the DC source from which the main thyristor derives the current Im and supplies it to the load. This forms the main circuit. T2, this capacitor, this inductor and this thyristor along with this voltage V or this voltage source V forms the commutating circuit or the circuit which is employed just for commuting the main thyristor T1. The sequence of events starts when thyristor T3 is fired. When this thyristor T3 is fired, current flows into this capacitor through this inductor and makes the voltage from 0 to 2V, where V is the voltage of the external source, the auxiliary source which we have just discussed. When the capacitor is charged to voltage 2V, thyristor T3 is self-commuted. Now, when we want to switch off, when we want to commute the main thyristor, what we do is we will fire thyristor T2. When T2 is fired, a voltage Vs minus 2V is applied at the cathode of main thyristor and this will commute thyristor T1. When thyristor T1 is turned off or when thyristor T1 is commuted, the capacitor will discharge through the load resistor at a rate which is determined by the load current. The load current is determined by the load resistor in fact. If load resistor has a high value, the load current will be small and vice versa. The capacitor voltage and capacitor current waveforms are shown in this figure. We can see that the capacitor voltage starts from 0 and when omega mt becomes pi by 2, it becomes V, and when omega mt becomes pi, it becomes 2V. The capacitor is fully charged. When T2 is fired, the capacitor discharges in this way. The capacitor voltage varies according to the relation Vc equal to V into 1 minus cos omega mt. Also, the charging current of the capacitor is given by the formula It equal to V root C by L sin omega mt. Now, this is the charging current. The charging current goes from value 0 to the maximum current V root C by L when omega mt is pi by 2 and it becomes 0 when omega mt equal to pi, and thereafter it discharges through the load resistor which is determined by the load resistance. If the load resistance is high, then the discharging will be in a slower pace. If the load resistance is small, we will have a fast discharge through the resistor.